this video I'd like to show you how you can create a serverless WebSocket API using AWS API Gateway. I'm going to start actually with a few basic features of API Gateway to give you a quick overview what you can do with this service from AWS. And let's actually start with a regular REST API, which will respond back to the client with some mock data. So, being authenticated in your AWS console, search for API Gateway, go in it. Once you're in here, you can see the types available to be built. So we can create a HTTP API, WebSocket API, that's our final goal, public REST API and private REST API, which can be accessed only from your VPC. We're going to create a public REST API. Let's build it. We're not going to use any examples or import anything. We're creating one from scratch. Let's call it REST API. Create it. Once it's ready, we can attach the resources to this API. The resources in this case are in fact the endpoints used by your application or any other API client to hit your API. So let's create a endpoint. Let's call it hello from mock. This is the endpoint. You can edit it as you wish. And let's create this resource. Once the endpoint is ready, we have to attach a method through which method this endpoint will be requested. You can choose any HTTP method available. Let's choose for this one the get method. And we're going to integrate with the mock. Save it. And in this flow, you can see the whole flow of the request from the client towards our mock endpoint and with the response back to the client. And at this step, we already can test some part of this API, specifically this endpoint, by hitting the test button. In here, if you have some query string params, custom headers, you can provide them here and hit the test. As you can see, the response body is empty, there's no data at all, and the response headers, it's application JSON. Let's go back and actually hard code some data in here to receive some proper body. So in the integration response, find our application JSON, and let's hard code in here the following message: status code 200, and the message, let it be hello from mock. Hello from mock. Save it. Go back. Let's test it again. Hit the test button again, and we can see the message is in here. So the next question is how we actually can test this thing from a real application or a real API client like Postman. Before doing this, we have to deploy this API. So let's deploy. We have to create a new stage. Stage is like your environment: acceptance, test environment, production. So let's create the test environment in here. It will be test environment, and the version we're going to deploy will be 1.0. Deploy it. Once it's deployed, we can see the URL for the whole stage. Pay attention, this is the URL for the whole stage. It doesn't include our endpoint hello from mock. And in here you also can track the deployment history, so you can easily roll back to another version if something goes wrong with your current version. So let's actually find the URL for our endpoint, which is this one, including the hello from mock. And once you try to access it, you can see the response, it's ready. Let's try right now to actually integrate these endpoints with a Lambda function and receive the response back from the Lambda function. So let's create another endpoint, back to resources, create another endpoint, another resource. Let's call it hello from Lambda. This will be our endpoint, create it. We have to attach a method to this one. In this case, let it be post. Save it. Let's integrate with Lambda. As you can see, we don't have any Lambda available at the moment. Let's create a new one. We're creating one from scratch. Let's call it REST Lambda. The runtime will be Node.js, and the permissions will be the default, the basic one, which also includes the permission to log all the events, all the data into CloudWatch. So let's create this function. It might take several seconds, and once it's ready, we can see the code editor from AWS, and this pre-populated code actually it's good enough for us to test our integration. Let's save it. It should reply back with hello from Lambda. So let's go back to our API. Let's refresh this page, and we can use our Lambda REST. You can use the drop-down autocomplete to choose your Lambda. Yes, we give it the permission to evoke our Lambda function. Okay. And the same way you can see the flow from the client or Lambda function, which will respond back to the client. And we can test it right in here. We can provide a payload. If the method is post, you can provide additional payload to the endpoint, test it, and we can see the endpoint in here. The response is here, the one coming from our Lambda function. Let's deploy this version to make it publicly available. It will be 110. Deploy it. Let's find, so in the deployment history you can see the current one, it's 110. You can easily roll back to the previous one, but let's keep it like that, and let's take the post one. So this is the endpoint. Let's go to Postman to create a new request. It was post, send, and hello from Lambda. It works. So far so good. And let's try right now to create the WebSocket API and integrate this WebSocket with a database service and log all the messages, well, all the communications, all the connections in that database, and propagate all the messages coming from one client to all the other clients connected to the same WebSocket. So let's go ahead back into our API gateway and create a new API. Create new API. In this case will be WebSocket. Build it. Let's provide a name. Let's call it WebSocket Server API. And let's create a blank API. Create. So once it's ready, you can see it looks slightly different from the regular REST API. First of all, it doesn't have these resources. There are no endpoints. For WebSocket, there's only one single endpoint, the WebSocket URL. And coming to that WebSocket URL, we can make use of this route selection expression. And based on this value, we can reroute the incoming request to different handlers. And there's already 3 handlers: connect, disconnect, and default. The connect will be triggered automatically when the new connection is established to our WebSocket. Disconnect when the client disconnects from the WebSocket, and we will create our custom one onMessage when a new message will be sent towards our server, towards the WebSocket server. So let's go ahead and try the connect one firstly to see if the API itself works. So let's create the connect. Let's integrate it with the Lambda function. At the moment we don't have any Lambda, so let's firstly go and create that new Lambda. Create a new function. Let's call it onConnect. Same runtime, the same permissions. In here, create the onConnect Lambda. So once it's ready, we have our response in here, the pre-populated code, which is good enough for us. Let's go back into our API gateway and use the onConnect. I think I have to refresh it. Let me refresh the page. So integration request, client. Seems like the WebSocket is slightly slow in AWS. I mean the dashboard. Integration request. We're going to integrate with the Lambda function called onConnect. Save it. Yeah, we'll give it the permission to invoke our function. And it should be ready. We should see the flow. Come on, AWS. Yep, we're here. We see the flow from the client towards our Lambda function. Let's wait until it refreshes. So this is the whole flow from client towards our Lambda function, and as you can see in the WebSocket there is no response back because WebSocket are pushing the data from the server to the clients when they feel it is necessary. So when there is some data ready for the WebSocket, it is pushing without actually having a request triggered by the client. So let's try to deploy this API. We have the production stage. Okay, we can create a new one. Let's call it test environment, test, and the version 1.0.0. Deploy it. We have our test. This is our test. Pay attention, we have at the moment two stages in here. Production tests. We just deployed it in the test environment. This is our version test. Let's use this endpoint. I have a small application which allows me to test the WebSockets. So in here you provide the WebSocket server URL. It will show the status if the connection is established or not. You can send a message to the server, and in here will be listed all the messages coming from the server to the client. So let's try to connect. Connection is closed. Let's try once again. Connection is opened. It takes a few seconds to deploy the whole application through AWS data centers, so don't worry about this. The connection is established, everything works fine. Right now if you try to send a message, we should see actually an error, because so this is the message we just sent, message 1, and this is the response from the server because there is no handler for these messages. Right now I'm going to create actually a handler for this onMessage action. So in our API gateway, go back to our routes, and I'm going to create the custom one onMessage, save it, and let me integrate it also with a new Lambda function, and this, let it be a completely new function called onMessage. Create new function, onMessage, the same default values, create a function, once the function is ready, something is wrong with their editor. Let's remove these things, deploy it. Let's go back to our API gateway. let's refresh the page, integrate it with a Lambda function called onMessage, and save it. And don't forget to deploy this in API again, otherwise you won't see any changes. So we have to redeploy it in test environment, the version be 1.10, deploy it, recopy the URL, go into this test page, provide URL, connect to the server, connection is established, and now we should be able to send a message 1 sent, and there's no error coming back because we already have the handler for these actions, which is onMessage. So far everything works fine, and the next step will be to simulate kind of a chat behavior where multiple clients connect to the same WebSocket, and when one of the clients sends one message, the WebSocket will deliver that message to all the other clients. This way they will be able to communicate one with all the others through WebSocket connection. So for this we'll need actually 3 Lambda functions, one which will handle the connections. We'll have to save all the connections, we'll have to send all the connections, we'll have to save all the connections into a database. onMessage, when someone will send a message towards our WebSocket server, that Lambda will have to retrieve all the connections from the database and to send that message to all those connections. And on disconnect, this Lambda will have to go to the database and remove that connection for that client from the database to make sure we don't deliver that message to a redundant connection which is not available anymore. And of course, apart from the Lambda functions, we'll need also a database where to save all these connections. And in this case, we'll use DynamoDB also from AWS. So let's go ahead and create first of all the database. Let's search for DynamoDB. Let's create a new table in here. Tables, create a table. Let's call it messages, and the key will be connection ID. Create it. So while the table is created, I'm going to adjust first of all the existing Lambda functions onConnect and onMessage, and I have the code already ready. It will be provided on my GitHub. So onConnect, let me walk you through the code. It's quite simple. So everything in the Lambda function starts with a handler. In the handler, we retrieve the connection ID from the incoming request from the AWS, and we're passing this connection ID to the addConnection function, which will return back a promise, and once this promise is resolved, it will respond back to the client with the status code 200. This addConnection, what this function is doing, it's receiving the connection ID and it's putting this connection ID into a table called messages, the one we just created, with the properties connection ID and the value which is coming from our request. This then DynamoDB client, it's a client available from AWS SDK. It's on NPM, so you can use it, you can test it, play around with it. So let's try to deploy it. And one more thing in here, very important thing, otherwise you'll face the errors. In order to allow the Lambda function to access DynamoDB, we have to provide the right set of roles of permissions. So let's go into permissions and the role name, and in here we have to attach a new policy, and this one is DynamoDB. I'm going to provide a full access of DynamoDB, but you have to be very careful with this kind of access because you have to provide the read, write, or delete access based on the your required scenario. But for these testing purposes, I'm going to provide this one, full access. So attach this policy. So this was our Lambda onConnect. Let me adjust also the onMessage. onMessage. I have the code for onMessage in here. It's also quite simple. Don't be scared. So everything starts with the handler. We initiate the gateway management API. This one is needed to respond back through WebSockets to our clients. We're receiving the message from the server, from the request, which is provided within the body. We get all the connections from the database. We're going through each connection. We send the message. So let's see what this init API gateway management API is doing. It's just initiating the API gateway management API with a specific version, which is this one, and it's using the endpoint for our WebSocket API based on the current stage we're using. So this will be test environment with the domain name, which was hit by the user when he sent his message towards our WebSocket. Next one is getting connections. It's connecting to the DynamoDB database to our table called messages, and it's scanning this table for all the items in the table and returns the promise. And once this promise is resolved, it retrieves the items of connections, and going through each item, it retrieves the connection ID and sends the message. And sending the message, it's using this client from AWS SDK, and it's posting to a specific connection with the connection ID and data. Data, it's our message which came from another client. And at the end, it returns back the status 200 saying that everything is okay. So this is the whole onMessage event. So let's deploy it, save it. And we have to attach the same permissions. In this case, we need two sets of additional permissions. One of them is for the DynamoDB, and another one is to use the WebSocket API Gateway Management API to be able to push the data to post to connection a specific message. So let's attach these two permissions to this role. So for the first one, I'm going to attach also the full access for DynamoDB. This one, attach policy. And the second one should be gateway invoke full access as well. Once again, please pay attention how you're using these roles, otherwise you may face some security vulnerabilities. Attach the role. And the final, let's go back to our API gateway. API gateway. And the final one will be the disconnect event. We have to create this one, but first let's create the disconnect function. Let's create a new function, Lambda function on disconnect, the same default values, create a function, and the disconnect code is in here. The function is being created. So in the editor, we provide a logic, and again, everything starts with a handler. It retrieves the connection ID which initiated the disconnect event, and we'll deleting from the database that connection ID, and we respond back with the code 200. And what the delete connection this function is doing is going also through DynamoDB table called messages, and is deleting this item with the key connection ID equal the ID we just received from the incoming request. So deploy it. Don't forget also to provide the permissions to access the DynamoDB. DynamoDB full access. So it seems like we have everything in place, and now we can attach the disconnect lambda to our disconnect handler. So onDisconnect, save it, okay. Is it ready? Yep, it's attached. You can see the whole flow from the client, request coming from the client towards our onDisconnect. So let's try to deploy this version into test environment. It will be 1.2.0 deployed. We see the versions we have at the moment. The latest one is 1.2.0. Let's copy the URL. Let's go into our application, refresh the page, provide the URL, connect. So it's successfully connected, and let's try to send a message. Message 1. Send a message there, and we received back from the server the message 1 because our onMessage went into the database, retrieved the connection ID, and passed back the message to that connection ID. And we can go actually to our database, to DynamoDB, and we can see in there the existing one connection. So the tables, messages, items, and this is our first connection ID. Right now, if we're trying to establish the second connection ID, let's connect to this one. Successfully connected. Let it be the client 2, message from the client 2, send message from the client 2. We should see in DynamoDB already 2 connections, 2 connection IDs, and in the first client we should receive the message from the client 2. So if we try to connect once again, the message connect this one, client 3, send. The client 1 should receive a message from client 3, client 2 should receive a message from client 3, and client 3 receives its own message as well. So right now, let's say the client 2 is trying to send message to 1, it sends the message, it receives the message itself, and all the other clients receive the same message as well. So that's pretty much it. It works like a chat. One client sends a message and all the others receive that message. So that's pretty much it. And in database we can see the existing connections. And if one client is closing the connection, so we close the tabs, we close two of those tabs, we should still see here only one client, because onDisconnect was hit, and that lambda attached to that onDisconnect event was triggered and removed the connection ID from the database. So that's how everything works with the WebSockets and how you integrate it with the AWS gateway.